So, hello guys. Today we are going to talk or discuss on differentiation from first principle. So we all know that during differentiation, we are always trying to find the tangent or curve of the tangent of a curve. Now, for example, we all know that this dy all over dx is always called the tangent of a curve, which is equivalent to either you can call it what y prime, or you can always call it what f prime of x when about one of this is given. They are all equal. Either we use dy over dx, or use y prime, or use what f prime of x. So now, the first principle here states that either we use one of these, we can say f prime of x here, when y is given as, for example, y is equivalent, for example, f of x. So, when x equals to what? X plus h. In our y here, in this case, y is equal to what? F of what? X plus h. Meaning, this x is equivalent to what? To x plus h. So from here we can say that our first principle states that we said y prime or f of x, f prime of x is equal to, we limit it to 0, we limit h to 0, lim as h tends to what? To 0 into what? F of x plus h minus f of x, the original equation, all over what? H. But remember that h approaches 0, but is not equal to what? To 0. Meaning, as the provided h is not equal to what? To 0. This is our first what? Principle. So we can use first principle to solve problem related to differentiation. Any kind of problem, either from multiplication, quotient, even what summation. Now, for example, let's assume we have something like this, that f of x is equivalent to what? A x plus b. So, this is our main, or this is our first equation, that is f of x. So, the formula from the first principle states that we need to find f of x plus h. Meaning, wherever we find x, we have to add the result with h. So then this means that this here becomes what? F of x plus h. Since this x, remember we say that x is equivalent to what? X plus h. Meaning, since here we have add x plus h in this case, then meaning we are going to add again here this a, that is what? This x become what? X plus. Here we have x plus h again go plus what? Plus b. Remember that our x in this case is equal to what? X plus h. Meaning we, from our equation, we need to find f of what? X plus h. Meaning we are going to add h which enable what? X. This is what we do. We add h here, we also want add h here. So now this here becomes f of x plus h here in this case becomes what? We have to open this bracket, we have x times a times x, we have ax. A times h here, we have what? Ah, then plus what? Plus b. Then we bring the principle here that says that f prime of x in this case is equivalent to what? Lim as h tends to what? To 0 into what? F of x plus h minus f of x all over what? H. So from here we can see that f prime of x in this case we lim as h tend to approaches 0. Now we have to substitute these terms here. Meaning our f of x plus h is equivalent to this. Then we can remove f of x plus h and replace with ax plus h plus b. Then we have ax plus ah plus b. Meaning f of x plus h is this, since they are equal. Then this minus sign, minus. What is our f of x? Our f of x is our original word equation, first equation 4. We say bracket ax plus what b. Plus, please don't forget to put the f of x inside the bracket, please, because of this negative sign. All over what? H here. This means that f prime of x is equivalent to what here? Is equivalent to, we say lim as h tend to 0, approaches 0 into ax plus ah plus b. Here we open the bracket, minus plus here, minus ax, again minus plus here, minus what? B. All over what? All over h again. So from here I can say that f prime of x is equal to what we lim as h tend to 0, and now ax minus ax 0. This will cancel out this, then b minus b again 0. Now it leaves us with only what? Ah over what? All over h. So this now h cancel out h. So our f prime of x is equal to what we lim as our h tend to 0 equals what? A. This is our what? Our final what? Our final answer. This is how we use first principle to solve any equation related to what? To differentiation. So now, let's for example now we have another question that states that if f of x in this case is equivalent to root 2x plus pi. Normally we can solve this question using what? Chain rule, but we were asked to use first principle to solve this question. So now I want to clean all this so that we can solve this beautiful question. So now remember the first step is to find what? F of x plus h. Then we apply our formula. And find f of x means we are to add, whenever we find x, we have to add what? H to it. Now we say now we have f of x plus h in this case is equivalent to what? Root into 2 bracket x plus h. Remember, we are to replace x with what? With x plus h. Then plus what? Plus 5. So now, this our f of x plus h in this case here becomes what? Root of what? 2 times x, we have 2x. 2 times h here plus 2h plus what? Plus pi. Open the bracket. So now this becomes, because we bring our rule, then f prime of x in this case here becomes what? We have lim as h tend to 0. Our f of x here is this. F of x plus x is this. We said root 2x plus 2h plus 5. minus our f of x, which is our original equation here before. We said root 2x plus 5 all over 1 h. So now we can solve this because this becomes something that we call solve. So meaning we have to use rationalization and conjugation of solve to solve this very question. So this here becomes, here I'm going to remove this so that I can solve this question. Becomes what? Root 2x plus 2h plus 5 minus root 2x plus 5 all over h. Remember, we conjugate it and we rationalize it according to what sort rule. Meaning we multiply, then this we take the rationalization of this step and we conjugate it now. To conjugate, wherever we have minus, it becomes what force to go. Then we have root 2x plus 2h plus 5. Remember, we are to conjugate it, meaning conjugation, negative sign becomes what positive and positive becomes what negative. So between this root here, we have a negative sign, meaning it's going to become a positive sign. Plus here, root 2x plus 5. Then we rationalize it again. It becomes here again over this root 2x plus 2h plus 5 plus again root 2x plus what 5. So now we multiply this by this on h by this again now. So yeah, this becomes what? Root 2x plus 2h plus 5 minus root 2x plus 5 times this cycle. We have root 2x plus 2h plus 5 plus what? Root 2x plus 5. Division sign. You see? We multiply this by this here, we have h times what? 2x root 2x plus 2h plus 5 plus what? Root 2x plus 5. You see, we multiply this by this and also h by this now. So now we have to open this bracket now. How? Here you see, because now we multiply this by this now. Here we have this times this. Since they are the same, then they are going to take square root. It's like we said x times x, here we have x squared. So now here we have root 2x plus 2h plus 5 square, since they are the same. Then next we multiply this by the second one. Here we have plus and go plus root 2x plus 2h plus 5. All together is what? Root 2x plus 5. Then next, we multiply this by the second one. Here we have minus times plus, here we have minus again this. Root 2x plus 2h plus 5, you see, times root 2x plus 5. Then now, we multiply this by this again, since they are equal. Minus plus, we have minus sign in this case. We have, since they are equal, we take the square of one of them, 2x plus 5 what? Square. All over what? Here we have h times root 2x plus what? 2h plus 5 plus root 2x plus 5. So now, square always cancel out root. This left us with 2x plus what 2h plus 5. So now these two are equal. We have root 2x plus 2h plus 5 times 2x plus 5 minus the same thing. It's like we say 2 minus 2 equals to 0. Then this minus this, things are the same, they are equal to 0. Then now this minus sign here, there's a minus sign. Then again, these two comes and this root again, square cancel out root. The remaining one we have 2x plus what 5. All over what? Remember, this will cancel out this because they are equal. They become 0. The remaining one we have h here bracket root 2x plus 2h plus 5 plus what root 2x plus 5. So then we open this bracket here, it becomes what? And now I can bring back our limit sign here in this case. We say lim as h equal to 0. We have this 2x plus 2h plus 5 minus plus here we have minus 2x minus times plus here we have what? Minus 5 all about h bracket root 2x plus 2h plus 5 plus root 2x plus 5. So now here we have this become what? Lim as h equal to 0, 2x minus 2x 0, means this cancels out this. 5 minus 5, again we have a 0 still. Now this remains us with only what 2h here. Since 5 cancels out from here again, 0. All over what? H bracket root 2x plus 2h plus 5 plus root 2x plus 5. So now this h can cancel out this h here. Now the remaining here we have lim 2 here, all about bracket what? Here we have all about root 2x plus 2h plus 5 plus again root 2x plus 5. So now in this case, we say that h approaches 0. When wherever we find h, we will replace it with 0. Since h approaches 0, and we have lim as h approaches 0 equals 2 all over here root 2x plus 2 times 0 plus 5 plus 2x plus 5. So now this here becomes what? Lim as h approaches 0 into 2 all over what here root 2x plus what? Plus 5 plus root 2x plus 5. Now these two are the same. Remember that we said if we have something like this, like root x plus root x, then as we say, since they are two in number code, we have 2 root x code. So now this here becomes what? Lim as h equals 0 equals to what? 2 all over, since they are 2 and they are all the same, we say 2 root 2x plus 5. And this 2 can cancel out this 2, remaining one here, and this leave us with lim. We can always h f prime of x equals to what? Lim as h equals 0, we have 1 all over what? Root 2x plus 5. This is our final answer. This is how we use first principle to solve this kind of problems.